Hey everyone, in this video I'm gonna use optical flow method and writing Python code, implementing on a video to get the frames and then computing optical flow for motion detection. So for this video, I'm gonna use this short video, which as you see, it is almost 3 seconds. And this is a car that when it's moving, there would be some smoking and some dust. That's part of this motion as well. So when we use optical flow on this video, it gets different frames per second and then computes motion between sequential frames. So before watching this video, I would recommend please watch my previous video about optical flow, which was Python code for optical flow estimation based on 2 sequential images. So in this video, I explain details of codes. So the basic is the same when we apply it on the video. So let's start and see how it goes. So the first thing is to import modules. CV2 is one important module for optical flow. Also NumPy as NP. Then because the video is my Google Drive, I would Google Colab import drive and then drive mount content G drive. Okay, then I would create a directory of the folder that this MP4 file is located. This is a directory. And one other module that I'm going to use it for plotting the image is from Google Colab patches, import CV2 image. So let's run. Okay, connect to Google Drive. Then it asks you to choose allow connection. Okay, mounted on Google Drive successfully. So the next step is we wanted to capture the video. So I'm gonna use video capture. Video capture as you see here. And inside that, it would be directory of this folder, and inside the folder, this is the name of the video. So in order to maintain the credit of the video, I wrote the name of the recorder, Abed Smile. So let's run and see. Okay, so we kind of captured the video. And the next step is to read the frames. When we want to read the frames, we can use capture read. So when we use capture cap read, there would be 2 outputs. One would be the return matrix, which is a Boolean matrix, true and false. And this one is the frame. So this is actually the first frame, but when you use it inside the loop, it's gonna use the next frame based on the number of frames and frames per second, which we're gonna talk about that in this video. So the next step is, let's write it first frame, because I'm going to define first gray, which would be CV2, then color change to gray color, or CVT color, first frame, then CV color BGR to gray. This should be underlined. Okay, so when we capture the first frame, this is a RGB frame. So here we converted the BGR to gray and define it as a first gray. It is because computation of optical flow on grayscale is more efficient, because we are computing the edges and pixel values, so it doesn't matter if it is red, green, or blue, it's just pixel values. Then we can run it and see, okay, there's no issue here. So the next step is we can compute the number of frames. In order to get the number of frames, for example, I define the length, then it would be an integer. So then I can say capture or cap, then get. Inside the gate, we can say CV2 and cap prop frame count. There would be other two features like a frame height and frame height, but I'm interested in frame count. Then another variable that is very useful here is frame per second, FPS, which would be capture get CV2 cap prop FPS. Then the third variable that I'm going to define is video duration, which is length per FPS. So we can print this value, for example, number of frames and we can also print frame per second, which is FPS. And finally, we can print video duration, which is this variable. And let's run it if it's okay, everything is okay. So the total number of frames in this video is 113, and frame per second is 29.97. So if we kind of do this computation length over FPS, the video duration would be 3.77 seconds. Now we can go to the next step, which is defining a mask, because I want to actually store the output of optical flow in this mask. So the mask would be numpy zeros like the first frame. It would have 3 levels, and inside each level I'm going to store a specific amount of information from optical flow. You will see that. Then the next thing to do is I'm gonna say the level 1 of the mask would be 255, and then I can go to the next section, which is very important. It would be the core of this Python code. So I would define one parameter, which is requested number of frame. So I set it as 5. It means that I wanted to get only 5 frames from this video. The reason that I'm gonna do that because extracting each frame from this video would be computationally very inefficient, and it's gonna crash your code. As you see, there would be 115 frames, and I'm interested only just 5 frames. So in order to define these 5 frames, I can define frames np line space from 0 to length -5. So from the first frame until the frame length -5, the reason that I don't want to choose the last frame is because the red output kind of shows false for the last frame sometimes, so it's better not to focus on the last frame. So line space and how many these requested number of frame. So this would be the frames, and also I wanted to define the d type as an integer. Okay, so another variable that I want to define here is frame count 0, which means that this is just the initial value for frame count, and inside the loop frame count would be increasing. So here I'm gonna use a while loop. Cap is open. So as long as the video is open, I'm gonna do some processing. So this processing would be extracting the frame. So here, instead of first frame, I would say just frame, because inside the loop it's gonna take different frames. Then I can make sure that if ret if not ret break. So it's gonna help us if there's nothing at the output of the read, we can break the loop because there's nothing to be computed inside the optical flow. Also, there is another important thing here. If frame count in frames, as I said, we don't want to compute optical flow for all frames. We just wanted to compute these chosen frames. And let's print frame just to talk about that easier. So when we run it, you see I requested just 5 frames, 0, 27, 54, 81, and 108. These are 5 frames that I'm interested to compute optical flow. You can obviously increase or decrease these number of frames. So if frame count, which starts from 0, is in these vector frames, we can compute optical flow. So one first thing here, we can ensure the frame. So which frame we are using for optical flow. And then we can convert the frame to grayscale. I would compute just frame gray, and this would be just frame. Then maybe just gray is enough. Then we can compute the optical flow. The output is flow and CV2 calc optical flow far and back algorithm. So inside the input of these function, I would recommend you to visit my previous video that I talk about the details of these inputs. But here I can just use information that I made before that. The first input is gray. The first input is pre-gray that I haven't created yet. So in order to create a pre-gray, I should define this one. This is the pre-gray. Let's run it to make sure this variable is created. Okay, so this is the initial gray value. Okay, so this would be the new gray value. So we have a previous gray, we have a gray, there is no flow. Pyramid scale is 0.5, number of levels of pyramid are 3, window size 15, 3 iterations, and these are kind of just subjective choices. You can change it as you want. So when we compute the flow, we are interested to kind of get the magnitude and also the angle of these optical flow. So I'm gonna use this function, which using the flow u and v. So this is the u vector, this is the v vector. U and v are two particles of a vector of motion in x-axis and y-axis. So I use function Cartesian to polar. It gives you magnitude and angle or direction. So when you have angle and direction, remember this mask that I created. Now I want to store this information into this mask. Level 0 of the mask includes the angle, and the level 2 includes the magnitude. So I also normalize the magnitude based on the mean and max, and also the angle should be converted to degrees. And so these masks can be converted to RGB. So this mask is created, and then here we convert this mask to RGB. Then we can easily plot this RGB mask, which gonna gives you kind of the output of the flow in very beautiful visualization. So maybe, and also we need to update the frame because this is inside the loop. Don't forget that. And flow is based on previous gray and gray. Gray is computed here. It's gonna give you a new frame, but you need to update the previous gray as well. Then we can write key weight, kind of waiting for user to see if the user wait key, excuse me, wait key 1 to see if the user press specific key. It's gonna be, for example, equals ord q. So here we wait to see if the user press Q, then it's gonna break from the loop because, as I said, the video may include many frames and it's gonna take time. Another thing that we need to update is frame count, which starts from 0 here. So here I can update the frame count. Then we kind of finish this loop, but the last thing that we can do is we can free space this capture and close all window. Destroy all windows. So let's run and see how it goes. I would like to run from the beginning just to update everything. So now you see that there's over here. I should revise it. See the wait key 1. And so this should be with K and with capital K. Try and see. Okay, so this part of the code is executed successfully, and here are the results. These are the frames that we chose. This is the first frame, the output of the optical flow, second frame, output of the optical flow, next frame, and so on. So the next part, I'm going to show the output of optical flow as a math plot. So I first define these dimension of the flow shape. Then I define spacing as 20 because the optical flow is too dense, and it's better to kind of reduce the resolution by spacing or undersampling. Then we can define new nx as int h over spacing and ny as int w over spacing. So this should be w, this should be h. Then I define the x vector numpy line space from 0 to w nx and d type np int 64. Define the same for y. This should be ny. Then we can define flow not dense based on the flow numpy ix y and x. By doing this, these are new indices I defined for the image to reduce the resolution, defining a not dense flow. Then I can define the u and v vector. This is 1, and uv magnitude. You know, uv are two components of the array in x and y axis. So numpy sqrt u power of 2 plus v power of 2, and I can also filter the u, something like if uv mag less than 3, then insert none. This is also for v as well. So here we finish the, so here there's a problem. Okay, it should be H and W. This should be W minus 1, H minus 1, because we start from 0. So yeah. Then the next step is to import matplot deep as PLT, define figure axis. I would like to define 1 by 1 panel and fixed size 20 by 20, kind of large to show everything. Then I want to create key arguments. Then for dict, I would say the angles would be X and Y. And scale units would be X and Y as well. Then here I can define other key arguments. Then I can plot the quiver function for plotting the arrows, the output of the optical flow, something like X, Y, U, and V, and keywords scale, for example, 0.8, and then we can also add these two lines because we want to reverse the Y direction, the Y-axis direction. It should be reverse because the image Y-axis has a downward direction, but the optical flow and this figure has an XY, which the Y-axis has an upward direction. Then also it's good to show the magnitude. Let's define the magnitude as a mask. You know, it was the magnitude, if you remember. So CMAP, HSV. So if we run it, this would be the output with plausible result. You see the car, the direction of the car here, in front of the car is moving this direction. These are the smoke of the car that kind of goes into the air in this direction. Just good to review this video again to see this is the direction of movement. And yeah, that was the optical flow for the video. Thanks for watching this video. I hope you enjoyed it.